And I've always been interested in flows of materials and resources, of which energy is one. And that's sort of how I came to this problem of looking at energy infrastructure as a flow. A lot of people have looked at the problem of how we deal with electricity under climate change constraints in the past, but it tends to be people thinking sort of from a very stylized economic model. How much is this going to cost? And there hasn't been a lot of work sort of on the ground thinking, well, actually, so there's been a lot of economic work from the top down, and a lot of people thinking about, okay, how are we going to integrate wind into the grid? Because there's a lot of problems with the variability and reliability of wind resources, for example. Or how are we going to integrate solar when the sun only shines during the day? But there hasn't been as much work sort of in the middle there thinking, okay, what exactly are we talking about here? If we start trying to reduce the emissions associated with our electricity production in the year 2025, and we have to make it to whatever goal by 2050, how much stuff are we actually talking about building, and what resources are associated with building that stuff? So that's sort of the problem I've been looking at, trying to sort of find this middle ground viewpoint where we actually think about the flows of construction and associated resources that we need to solve this problem.